Okay, this is a quick an explanation of how to determine the volume, or in other words, eventually the capacity of your boat. So I'm going to do it with an example. This is not from any real boat. I just came up with some numbers that could work where this vertical axis is the cross-sectional area of the individual stations. So I have a forward perpendicular, station 1, 2, 3, all the way to station 9, and an aft perpendicular. I had, on this image, I've got 1 foot, 1 foot, 1 foot, so on between stations 2 and 3, 3 and 4, 4 and 5, 6 and 7, 7 and 8. I have 2 half foot between aft perp and station 9, and station 9 and station 8. Also station 2 and station 1, and station 1 in the forward perpendicular. The total length of waterline is 8 feet. So I've got 1, 2, 3, 4, 5, 6, 7, 8. So that's where my 8 came from. And at each station, I have area values. So for example, station 5 might look something like this. And perhaps the water line goes like this, and I calculated this area to be 0.46 feet squared, and that would be this value here, and so on. So I did that for all of the stations. Okay, so now the general concept is each one of these represents an area at a particular section. If you multiply that area across a distance, a linear distance of the boat, we're going to end up with volume, because it's feet squared times feet. So this, for you calculus people, you'll recognize that the area under an area function will give you volume. So the way we're going to do that is we're going to approximate it, because we don't have the actual function in a mathematical formula like you would in a calculus problem. We have a real-life situation which is a whole bunch of values, but not necessarily the formula for this function. So what I'm doing is I am connecting point to point on my area of curves example. This is going to generate more of a geometric figure, or a series of figures that will actually be trapezoids. So that's why this is known as the trapezoid method. And then for each one of these, we have something like this. So we're going to end up, I'm going to end up drawing, that should have lined up a little bit better. Not. This isn't a real boat, so these things should have lined up a little bit better, but no big deal. So I'm going to have 1, 2, 3, 4, 10 areas to get. I have these values, 0.05 feet squared, 0.15, and I also have this distance here of 1/2 foot or 1 foot. So the formula for the area of a triangle, we'll say area 1, which is a triangle, is the base 1/2 times the height, which is 0.05, times 1/2. Area of a triangle is base times height divided by 2. And we're going to I'm going to calculate that is, see if you can see a little better, 0.5 times 0.05 times 0.5. That gives me 0.00125 feet squared. And I'm going to carry this all the way through for each one of these. So for part 2, area 2, that's a trapezoid, which is 1/2 base 1 plus base 2 times height. So in our case, it's 1/2 of base 1, which is 0.005. I'm sorry, 0.05 plus 0.15 times this base, which is also 1/2. So I've got 1/2 base 1 plus base 2 times the height of this trapezoid, which is base, base, and height, is in this formula. So I'm going to do 0.5 times 0.05 plus 0.15 times 1/2, and that's 0.05 feet. I incorrectly put over in the previous part feet squared. That's actually feet cubed. This is feet cubed. So I'm starting to generate a volume. I'm going to pause the video here, finish these calculations, and show you what to do next.